They've created a camera so fast it slows to a crawl the fastest moving thing in the universe, light.
The camera has a resolution of 1/1000,000th of a frame per second. And so we can actually observe light as it goes through this scene.
1,000,000,000,000 frames per second?
Mm-hmm.
At that speed, a flash of light on a still life is transformed into a journey.
We'll see light coming in by its reflection off the floor.
Oh, wow.
As the light wave propagates, it'll hit the surface of the fruit and we'll see that light up. And then only after delay will you see the light hit the wall behind it, and only after another delay will you actually see the shadow behind it.
Wait, so the shadow doesn't appear instantaneously?
That's right, because the wall is farther away, it takes light longer time to reach it.
That's crazy.
So let me show you another example.
It may seem unremarkable at first, a soda bottle filled with water, but then a flash.
So you see the pulse of light enter in from the left.
This pulse is actually a packet of photons, particles of light.
And we can see its energy front sweeping across the bottle from left to right. And eventually the pulse will hit the cap and emit a bright flash.
Just think how fast it was traveling.
About 600 million miles per hour.
And how long did that event take in real life?
It took 1/1000,000th of a second for light to go from one end to the other.
So an event that took a nanosecond, it has been stretched to
about 20 seconds.
20 seconds. So that's a lot of stretching.
This is super slow motion.
Put another way, if you were to film that iconic apple with this camera and made a movie of the bullet entering the picture, going through the apple and out the other side,
it would take about a year to watch this entire movie.
This would take a year to watch?
That's right, yes.
Oh, I recognize